Next, SF at point C. Now that will be equal to, this shear force between B to C will remain constant, but the moment I take section to the right of C, here I have 71.67 minus 40 and minus 40. That gives me 8.33 negative kilonewton. After getting shear force at point C, now this shear force will remain constant between C to D because there is no load. So shear force at point D will be same as shear force at point C. Now after this shear force at point E, here also I will be having two values. At first to the left of E, where I am not considering reaction at E. So here I have SF at point E is equal to 71.67 minus 40, again minus 40, and then 15 into 5 downward, so again it is negative, so minus 75. So here I get my answer as 83 point, which is negative, minus 83.33 kilonewton. Now we will get one more value of shear force at point E. That will be by taking the section to the right of E. So here I have, if I take the section to the right of E, RA, which is upward, 71.67 minus 40 minus 40 minus 75 and plus 113.33. So that gives me an answer of plus 30 kilonewton. Now this shear force will remain constant up to point F because we don't have any load between E to F. Now once we have calculated shear force at each of the points, we can easily draw the shear force diagram. So for that I will draw the beam once again. This is the beam which is given in the question. Now to draw shear force diagram, we would be projecting the point downwards. Next, the length of shear force diagram will be equal to the length of the beam. Shear force at A, the value which I have, it is 71.67 kilonewton positive sign. So here I have positive sign, means it would be above the line. Next, at point B, I am getting shear force value as 31.67 kilonewton, again positive. Now as there is UDL between A to B, this shear force will be an inclined line. Next, between B to C there is no load, so shear force will remain constant. After this, at point C we are having shear force value as minus 8.33 kilonewton. This shear force will remain constant between C to D. At point E, we are having two values of shear force. One is minus 83.33 kilonewton and the next value is plus 30 kilonewton. Now we have reached up till here, that is 8.33 kilonewton at point D. From D to E there is UDL, so shear force will be an inclined line. Next, at E we are having two values, so from minus 83.33 it goes into plus 30 kilonewton, and between E to F, since there is no load, this shear force will remain constant. So now here I have positive and negative sign above the line and below the line respectively. So this is the shear force diagram which we have. And here we complete step number 2. Now step number 3, calculation of bending moment.